Hello, students, and welcome to our algebra lesson about linear inequalities. We have done linear inequalities before. This is more of a review to get you ready so that we can solve systems of linear inequalities. So we're going to start by responding to our do now. Let me get a darker color there. Responding to our do now. The prompt is about raising awareness. We will begin solving linear inequalities today. That is our objective. Our essential questions are, how do I graph linear inequalities? And how do I represent the solution to, well, first of all, just a linear inequality today and tomorrow to a system of linear inequalities. Our assignment will be to do our do now in class notebook. We will complete problems 1 through 8, and there's a few notes to write in this lesson. And we will complete our exit ticket in class notebook. And all important, this is where you get your paycheck in the form of a grade and recognition for your work. Please upload your completed assignment in Teams. So we have an exit ticket that asks us about graphing linear inequalities. We'll get back to that. And our homework is homework 5.7, problems 1 through 12. Remember these important notes. You want to put your camera on, respond at the beginning, middle, or end of the period, be engaged in the lesson, and if you have any questions, write to me. Make sure that you get credit for your hard work by uploading the photo into Teams. Let's get back to our lesson here. We start with our do now, which is about this notion or this idea of raising awareness. So we're talking about raising awareness at home. Good things start at home, right? So what are of these topics, or maybe one that you think of yourself, which one should receive more attention? Is it time for you to raise awareness about your personal space, about COVID-19 issues, maybe about household chore issues or issues surrounding your education or learning, or maybe you've got something else on your mind that we should raise awareness of? I want you to write your thoughts right there. You have an exit ticket today that we'll get back to, but let's get on to our topic of linear inequalities. Okay, so first of all, what is a linear inequality? It is similar to a linear equation. Oops, sorry about that. So similar to a linear equation, but it uses the inequality symbol. And those are greater than, less than, greater than or equal to, less than or equal to. The solution to a linear inequality is all of the ordered pairs that make the inequality true. So remember, those ordered pairs are the points. Now, we have our first example, and we're going to determine which ordered pairs are solutions to the inequality 2x minus 3y is less than 15. So we're going to substitute 2, 5. So 2 is our x value, 5 is our y value. Let's make our substitutions using parentheses. 2x minus 3y, which is 5, is less than 15. 2 times 2 is 4. minus 15, 5 times 3 is 15, is less than 15. 4 minus 15 is negative 11, is less than 15. Is this inequality true? It is. So this ordered pair is a solution to this inequality. Let's try the next ordered pair, -1, -7, same thing. So 2, and our x is -1, minus 3, and our y is -7, is less than 15. So that would be -2 plus 21, because a negative times a negative is a positive, is less than 15, and that would be 19 is less than 15, which is a false statement. So this is not a solution. So this x and y value do not work. Let's try the third group, which is an x value of 3 and a y value of -4. So again, we just make our substitutions. 2, and our x value is 3, minus 3 with an y value of -4 is less than 15. So that would be 6 plus 12 is less than 15. 6 plus 12 is 18, and 18 is not less than 15. So this ordered pair is not a solution to this inequality that we are given. And finally, let's try the values 0, 0, which is the origin on our Cartesian plane. 2 times 0 minus 3 times 0 is less than 15. 0 minus 0 is less than 15, and simplifies to 0 for completeness is less than 15, which is a true statement, which means that this ordered pair 0, 0 is a solution to the inequality 2x minus 3y is less than 15. Let's take a look at that with Desmos. So here's our 2x minus 3y is less than 15. And the first ordered pair that we tested was 2, 5, which is right here. Here's 2, 5. And you can see that that is a solution. The second ordered pair is -1, -7, which would be right here. And you can see that's not in the shaded area. It's not part of the solution. Then we also had 3, -4, which is right here, 3, -4. You can see that is not in the shaded area, not part of the solution. But our fourth tested point was 0, 0, the origin, and you can clearly see that the origin is part of the solution. So let's go back to our notes. So when we graph linear equalities, we can show that all of the ordered pairs that are part of the solution, okay? So as we did with this Desmos, all of this shaded area, this pink area, every point in this pink area is part of the solution to that inequality. So what are the steps to graphing the inequality? So first, we want to put the inequality in slope-intercept form, right? Which allows us to easily graph it. Now, when you work with an inequality, you always have to remember to flip the inequality symbol if you multiply or divide by a negative number. So that's step one. The next thing you'll do is to graph the line. Now, when you graph the line, you want to use a solid line for less than or equal to or greater than or equal to symbols. And you'll want to use a dotted line or dashed line for less than or greater than. So let's go back. Well, let's look at step 3, and then we can go back to the Desmos graph. So step 3, we shade the graph. We shade above the line when we have greater than or equal to, and we shade below the line when we have less than or equal to. So let's look at that again. So we have our dotted line because we had a less than symbol. We are shaded above the line. Now, this is a little funny. We did not put this in slope-intercept form when we inserted it into Desmos. But if we were to put this in slope-intercept form, it would be a greater than symbol because we would divide by -3 and we would have to shade above the line. You'll see that as we practice these. So we have an example. We've got our 2x minus 3y is less than 15, which is the same problem we did up here. And what I just mentioned is what we're going to illustrate right now. So first, let's put it into slope-intercept form. So we don't have Desmos to help us now. We're going to do this by hand. So first thing I'm going to do is move the x value over, so I will have -3y is less than -2x plus 15. And then everything needs to be divided by -3. Which will give us y. Now we divide it by a negative. We flip that inequality is greater than 2/3 x minus 5. So we have a greater than symbol, which means we will have a dotted line. And we will shade above the line when we graph this. So we start with the y-intercept, which is -5, and we have a slope of 2/3. So rise of 2, a run of 3, a rise of 2, a run of 3. And we need to make a dotted line, put arrows, and then we will shade above the line. And that's the graph. Now, again, let's compare that with the Desmos graph. The Desmos graph, of course, is much prettier, but it's the same graph. I hope you can see that. All right, let's move on. We've got 8 problems, and let's tackle those now. So when we look at this greater than symbol, that means we will have a dotted line, and we will shade above the line of the graph. So we've got a y-intercept of -5, 1, 2, 3, 4, 5, and a slope of 1/3, 1, 3, 1, 3, 1, 3. Let's put that dotted line in. And arrows, and we will shade above the line. Now, some people shade different ways. You'll have your own artistic way that you do this. Not a very good artist, but it is accurate. Let's compare it with Desmos. And there it is. Much more beautiful in Desmos than my drawing. So let's look at number 2. We have less than or equal to, which tells us we will be working with a solid line because of the equal to symbol, and we will shade below the line. So let's graph that. We have a y-intercept of -1 and a slope of -2, which is a rise of -2 over 1. And Let's draw our line. Put arrows and shade below the line. That's our solution set right there. Let's take a look at Desmos. That's the second one. Oops, wrong problem. There it is. There's our line right there. Again, the angle might look a little different if I expand the graph. Now you'll see that the angle is exactly the same. Okay, moving on to number 3. We need to convert this to slope-intercept form. So first thing I'll do is move 5x over, so I'll have negative 2y is greater than negative 5x plus 12. I will divide everything by negative 2. I have 3 terms here that I'm dividing, which leaves me with y. I have to flip the inequality, so I will have y is less than, and the slope is 5 over 2x minus 6. So let's graph this. We have a y-intercept of negative 6 and a slope of 5 over 2. It's a positive slope, 5 over 2. It's a pretty steep graph. And with this, we will have a dotted line and we will graph below or shade below. Let's compare our graph with Desmos. And there we have it. Definitely more beautiful in Desmos, but certainly we are accurate in our graph. All right, number 4. Again, step 1, put it in slope-intercept form. Excuse me, I'll start by moving x, which will make x negative. So I have negative 4y is less than negative x plus 8. And I'll divide everything by negative 4. And now I have to flip the inequality. So y will be greater than positive 1/4 x minus 2. And here's our y-intercept of negative 2 and our slope of 1/4. Now let's take a look at this. We're going to have a dotted line, or dashed, you can call it dashed, and we will be shading above the line. So the slope is 1/4. It's a very gradual slope. And let's take a look at Desmos' graph. And there it is. There's our dotted line, our y-intercept of negative 2, and our slope of 1/4. You can easily see that slope on the Desmos graph. We're halfway done. Let's look at number 5. Again, with number 5, I'm going to move x over, which will make it negative. So I have negative y is greater than or equal to negative x plus 8, and I will divide everything by -1, which means I need to flip the inequality. Y is less than or equal to, and -1 divided by -1 is +1. That's an invisible 1, minus 8. So we will have a solid line, and we will shade below. So our y-intercept is -8, and our slope is 1. And let's draw our solid line. And we'll shade below the line. And there's our graph, and let's compare it with our Desmos graph. There it is. And that's what a slope of 1 looks like. And a slope of -1 would be exactly the opposite. Okay, number 6, we will move the 3x immediately to the other side, which will give us 2y is less than 3x, negative 3x, because we moved 3x to the other side of the inequality sign. We'll divide everything by 2, and we have y. And we do not need to flip the inequality because we did not divide by a negative. Y is less than -3/2x. Okay, we do not have a b value, slope-intercept form, y equals mx plus or minus b. We don't have a b value. That means that this graph goes through the origin. So our b value equals 0. So you can think of this as plus or minus 0 here, but we don't write that. We have a slope of -3/2. With this inequality, we will have a dotted line, and we will shade below. Now below is going to look almost like it's to the left because of the slope. So let me show you what that means. We have a rise of -3 over a run of 2. Let's put our dotted line in. And see how it almost looks like we're shading to the left, but there, even with a steep slope, we're still shading below the line. Let's compare it with Desmos. And there's our graph going right through the origin right there. All right, let's continue on. We have y is less than -4. So we have a slope of 0, right? So we have a slope of, if it were y equals -4, you would just draw a line. Well, in this case, y is less than or equal to -4. So we go to -4, and we have no slope. We have less than or equal to, so we have a solid line. Because it's less than, we're going to shade below. And this is what our graph will look like. Okay, no slope. So y is less than or equal to -4. Let's compare that with Desmos. And there you have it, though. There's our y-intercept of -4. And our final problem, we have 8x, is greater than 7. So we find 7 on the x-axis, 1, 2, 3, 4, 5, 6, 7. And with less than, we will have a dotted line. And because we're talking about greater than, now be very careful here. Technically, we are shading above, but what we're doing is we're shading above the value of 7. And let me show you what that looks like. So first we'll put our dotted line in, graphing our dotted line carefully, put the x's. Now, above the value of 7 is actually, in this case, shading to the right of the line. So let's take a look at that in Desmos. And here we have it. We're shading everything to the right of x equals 7. So let's go back. For homework, you have 12 problems. And let's go back to our exit ticket. To graph a system of linear inequalities, okay, use a solid line to graph less than or equal to and greater than or equal to symbols. Use a dotted line to graph less than or greater than symbols. Now, with regard to the shading, shade above the line greater than or greater than or equal to symbols, and shade below the line for less than or equal to symbols. So there you have it. Now you not only know how to solve a linear inequality, but you know how to graph it as well. And after we do this, tomorrow we will move on to systems of linear inequalities. So please do your homework tonight so you get that practice. Please upload your finished work, your photos, into Teams. Keep practicing, keep working at it, keep working hard. You're doing great. And as you keep practicing, you'll continue to be great.